We need to continue the subtopic unit tangent and normal vector of vector value functions. K.G.Tay from FKEE English Chemistry. Unit tangent and normal vector. Okay, let the C is a smooth curve represented by vector value function RT. Let C is a smooth curve represented by vector value function RT on an open interval I. So tangent vector to the curve C represented by RT here is equal to R prime T. Okay, and one unit of tangent vector to the curve C denoted as a capital T, the bracket T. This is unit tangent vector is a function of T because R is function of T. If you differentiate, you still get a function of T and is a vector T value function. So unit tangent vector will be the R prime T divided by magnitude of the R prime T. So one unit of the tangent vector. And the principal unit normal vector is again tangent vector and normal vector will be orthogonal or 90 degree. So the unit normal vector is again T prime T divided by magnitude T prime T. From RT you get R prime T. So, and then you find magnitude of R prime T. After you get the unit tangent vector, you differentiate K dt you will get T prime T. You find its magnitude. So of T prime T, then you get the unit normal vector. Example 1. Find unit tangent vector dt and principal unit normal vector nt for the vertex given by RT equal to 2 cos Ti plus 2 sin Tj plus 2. Find the unit tangent vector dt. Okay, from RT to find the R prime T plus R prime T. So you delineate each component, the differentiation of vector value function, you still get vector. So you get negative vector. This notation, another notation to represent the vector. Negative 2 CT. So in the symbol lesser than. So this stands for component I. So component J I differentiate respect to T, you get 2 cos T. So this is equivalent to negative 2 sin Ti plus 2 cos Tj, and the component K dt T. This is another notation to write vector. Okay, and then to find magnitude of the vector, we have the square root, square each component and sum it. So you have 4 sin square T. This also 4 is the R plus cos square T plus 1. Square this one 4 sin square T square T. Component J 4 cos square T. Square 1 is 1. Sin square T plus cos square T is 1. So probably we have sub 1. Sub 5. And then now your dt, unit tangent vector dt is actually given by R prime T divided by magnitude R prime T. 2 sin T I plus 2 cos T J plus 1K divided by the magnitude of R prime T, which is sub 1. So it obtains the unit tangent vector. Now we would like to find the NT. Unit tangent vector that we find just now, T. negative 2 sin ti 2 cos tj plus 1k divided by sec phi divided by sec phi. To find t times t. dt each component, so dt negative 2 sin t become negative 2 cos t. This is a denominator is scalar, so just follow. This is scalar. Differentiate 2 cos t negative 2 sin t. Differentiate 1 is 0. So come two-dimensionally, negative 2 cos ti minus 2 sin t 0. To find magnitude of t times t. Magnitude of vector square root square each component. So 4 cos square t plus factor of 4. This one is 4. So cos square t plus sin square t. And square t, the denominator, square root 5 becomes 5. Cos square t plus sin square t is 1. So we have square root 4 over 5 equal to 2 over 6. Okay, hence the NT, principal unit normal vector, will be t times t divided magnitude t times t. Differentiate is here. Negative 2 cos t negative 2 sin tj divided by sec phi. This is a t prime t. And then divided by magnitude, which is 2 over sec phi. So you notice numerator, this is at bottom, and then 2. So we get the principal unit normal vector, which is negative cos ti negative sin t. So this is the given the vector value functions. Defines a unit tangent vector. This is unit normal vector. Example, let the RT equal to, let vector value function RT equal to ti plus t squared j find unit tangent vector dt and principal unit normal vector nt then t equal to 1. Since similar to just now, only evaluate it when t equal to 1. So in that of RT, we differentiate to get R prime t. ddt RT you get R prime t. So ddt ti you have 1 I. ddt t squared j you have 2t j. Okay, and then you find magnitude R prime t. So square each component, so we have 1 and then add up with square of the component j, so this is 4t squared. So you notice example 2, your magnitude is not a constant value but it's function of t. So when you later when you find the unit normal vector, you need to use quotient rule to do the differentiations. Okay. Then the dt is r prime t divided by magnitude r prime t, which is 5 plus 2tj divided by magnitude, which is square root 1 plus 4t squared. It comes with t when time t equal to 1. Unit tangent vector when t time t equal to 1. So plug in t equal to 1. So you have I plus 2 0. Because t is 1. And then to find nt, you need to differentiate the dt. Dt that we obtain is I plus 2 divided by 1 plus 4t squared. So find t times t. Compared to example 1, a denominator constant. So you just take follow, but now numerator you have function of t, denominator have function of t, so you have this one. And you have ddt to v. You have the result v 2 pi minus q pi divided by v squared. So we use the quotient rule formula to do the differentiation. So p which is p which is 1 plus 4t squared. This is p. U prime k, which is I plus 2pj to differentiate it. We only get this is differentiate 1 is 0, differentiate 2p is 2. This is function of t multiplied with k, actually we have 2j. So minus u, which is I plus 2pj, they multiply with p prime means you ddt 1 fifth, the ddt here, ddt, the square root is 1 plus 4t squared, okay, dt 1 plus 4t squared, you have, and then power half, square root is power half, so for differentiation you have power half, and then 1 plus 4t squared, power negative half, and then ddt 4t squared, you have 8t. So simplify, we have total you have 4t divided by square root 1 plus 4t squared. Divided by t squared. So t squared it will become 1 plus 4t squared. Here, t prime half, and then for differentiation power half minus 1. So half minus 1 minus half is actually bring it down to come divided by square root 1 plus 4t squared. And then you have to differentiate 1 plus 4t squared, you get 8t. So 2 and 8t simplify at 4t. Okay, and then now this one, second term we have to divide by square root, okay, square root. So this one, if I want to have the same denominator, so that I can combine first term and second term, so I divide 1 plus 4t squared. Then I need to multiply square root 1 plus 4t squared. So exactly multiplied by 1 won't affect the result. Okay, now we can combine these two terms. How's it happen? Okay. 1 plus 4t squared times 1 plus 4t squared, so total is 1 plus 4t squared. Okay. Square root, so become power 1. Okay, multiply with 0i plus 2tj. So minus, this one you can expand it. So total you have 4ti plus 2t times 4t, so it's 8t squared j. So that square root is we have 1 plus 4t squared. The power half divide again by power 1, so total is power 3 over 2. this one, then like half, and then divide again by power 1, so total is power 3 over 2. Okay, now we can simplify, select, okay, component I for here is 1 plus 4t squared times 0i, so component I for first one is 0, so you have this is a component J. Okay, you have FKEE 0, so component J is 2 plus 8t squared. So minus 8, this is 4 8t squared divided by 1 plus 4t squared power 3 over 2. We will simplify. So this one 0i minus 4t. So component I have negative 4t. Component J 2. Then 8t squared plus 8t squared. Okay. Total will be 8t squared minus 8t. So it left only 2t divided by 1 plus 4t squared power 3 over 2. Okay, this is only t prime t. Later you have to find the magnitude of t prime t. Then you can use t prime t divided by magnitude t prime t. Then you can find the unit thick normal vector. So here of t prime t, negative 4ti plus 2j divided by 1 plus 4t squared power 3 over 2. Okay, the dt, we have this negative 4ti plus 2j divided by 1 plus 4t squared power 3 over 2. Divide by 1 plus 4t squared power 3 over 2. So magnitude t prime t, magnitude negative square root. Okay. So you square each component. So 16t squared. 2 you square it 4. Numerator square it, so it becomes 1 plus 4t squared. So become power 3. Power 3. Simplify against the numerator. 4. This one 4. Factor of 4. So this one you got t squared. 4 times 4 t squared plus 1. Okay, divided by 1 plus 4t squared power 3. So, this one becomes 2. 4 by 1 plus 4t squared power 2. Taking square root, so like 2 over 1 plus 4t squared. So this is a magnitude t prime t, you get 2 over 1 plus 4t squared. Hence, the unit normal vector nt, it will be your t prime t, this one is t prime t divided by magnitude t prime t. So t prime t is here, negative 4ti plus 2j divided magnitude t prime t. 1 plus 4t squared power 3 over 2. Okay, divided by magnitude t prime t, which is 2 over 1 plus 4t squared. 4ti plus 2tj divided by 1 plus 4t squared power 3 over 2 times the division table. The inverse is 2 1 plus 4t squared divided by 2. Negative 2ti, this is 1j, okay, 2 and here select together, so 1 plus 4t squared divided by 1 plus 4t squared power 3 over 2, this is power 1, this is power 1, okay. So we select down here 1 plus 4t squared power plus 3 over 2, this one bring down is minus 1, 3 over 2 minus 1, so become power half. So this is a unit normal factor, negative 2ti plus 1j divided by 1 plus 4t squared half. Your t prime t that obtained is negative 4ti plus 2j divided by 1 plus 4t squared power 3 over 2. So you notice it if the, just now I said, if the magnitude of your, if the magnitude here, r prime t is not constant value, so you find t is still okay, but when you want to find t prime t, you need to use a quotient rule. Because we have the u is a vector, the v is a function of t, so you use a quotient rule, ddt u v is du prime minus 2v prime divided by v squared. So our script will be a little bit complicated for t prime t, because the denominator is function of t, so when you want to find scale magnitude also a little bit troublesome. Okay, but so you have to do it carefully. Example. The third example. Oh, say having done. So we want to evaluate it when t equal to 1. So we already find t1, so we need to find n1. Okay, so for n1, plug in t is 1, n1. T is 1, so we have negative 2j, 1, negative 2i plus 1j, okay, here become 35, because t is 1, so divided by 35. The answer, okay, when t equal to 1, n1 is negative 2i plus j divided by 35, because we plug in t1, this one is 5, so power half is 35. So negative 2i plus j divided by 35. We now move to the third example. Okay. Find nt and n1. So before you can find nt, you have to find dt. Okay, so from here, r prime t, ddt 3ti, you have 3i, ddt 2t squared, so you have 4tj. Okay, magnitude r prime t. 3 squared is 9 plus 4t squared will be 16t squared. So t prime r prime t here is function of t. Then say when find nt will be a little bit troublesome, because you have to use quotient rule to do your differentiation. So the dt is r prime t divided by magnitude r prime t is 3i plus 4tj. We write, if you don't want this notation, you just write 3i plus 4tj. if your r prime t is square root, it is square root 9 plus 16 t squared. Okay, so if you want t1, t1, substitute t by 1, so 3i plus 4j. So when t is 1, we have here always square root 25, which is 1. So from dt here, differentiate respect to t to get t prime t. So differentiate 3, you have, so component I become 0. Oh yes, I cannot directly differentiate because you have 2v, 2 over v, right? So you have to use, say, the quotient rule, ddt u t dt v u over v, sorry. U over v is v u prime minus u prime divided by where the v is square root 9 plus 16 t squared. V u prime, differentiate 3i is 0. So differentiate 4tj you have 4. So minus the u, which is 3i plus 4tj. Okay, and then so differentiate the v, so your v prime is actually you have half 9 plus 16t squared. V is your square root. Square root is power half, is that? Bring the power front, so half. Then power half minus 1, so become minus half. And then your ddt 9 plus 16t squared you have. This is 32. So you simplify here, you will get this is actually 16t, power minus half, bring down. So you have 9 plus 16t squared divided by t squared. So square root is squared, it becomes 9 plus 16t squared. Okay, then this now combine these two, makes they get the same denominator, which is 9 plus 16t squared. So top you also have to multiply 9 plus 16t squared. So you multiply this by this, so can come 1, so times 1 you get back the same expression, which is square root 9 plus 16t squared. So now we have the same denominator, we can divide it together with 9 plus 16t squared as in example 2 just now. So square root, okay, normal square root, we have 9 plus 16t squared multiplied with 0i plus 4t. Then this one, okay, as one vector, 3i times 16t, so is 48t. Component j, 4t times 16t, so 64t squared. Okay. And then square root, combine, okay, square root, so is how square root, the denominator is square root, power half, combine here power 1, so total is power 3 over 2. Okay, and then the first term, component I no more. Okay, only component J. So first term component I is 0. So second term we have component I, which is negative 48t. Okay, and then for first term you have component J, which is 9 times 4, which is 36. And then this one is 4 times 16t squared, you have 64t squared. Okay, minus this 64t squared, so you just left 36j divided by 9 plus 16t squared power 3 over 2. So this is t times t. Negative 48ti plus 36j divided by 9 plus 16t squared power 3 over 2. Okay, so you have to find magnitude t times t. We go to the new page. Right again, t times t, you get is negative 48ti and then 36j divided by 9 plus 16t squared power 3 over 2. Negative 48ti plus 36j divided by 9 plus 16t squared power 3 over 2. Okay, and then you can now find the magnitude of the t times t. What to factor out this result? 12 about 12 times of negative 4t. This is 3 times. The numerator I factor out 12. Negative 48t, 36 out 12 is 3. Divided by this 9 plus 16t squared power 3 over 2. Okay, now you find the magnitude t times t. Okay, square root. So each component you square it, so 12 squared. 12 is squared. So this is vector. So you have similar vector. So okay, after we squared, the magnitude is no longer vector, become constant. Sorry. So no longer vector. And find magnitude. Okay, magnitude of a vector is scalar. So 12 squared, negative 4t squared, we have 16t squared. And then plus component j, you squared it, so this is 9. Denominator also squared it, so become 9 plus 16t squared power 3. So now why I just factor out so I can cancel this 2. So 12 squared, 12 squared 9 plus 16t squared is power 1. So this will cancel 1, so power 2. So you have 12 squared divided by 9 plus 16t squared power 2. Simplify the square root, so you have 12 over 9 plus 16t squared. Translate your NP. The principal unit normal vector is t times t divided magnitude t times t. Okay, t times t is 12 times of negative 4ti. Total is negative 4ti plus 36j divided by 9 plus 16t squared power 3 over 2. Divided by 12 over 9 plus 16t squared. 14i plus 3j, 9 plus 16t squared power 3 over 2. Multiply, reverse it, so 9 plus 16t squared divided by 12. So this is power 1. So simplify with here, you left power half. So So lastly, your answer is negative 4ti plus 3j. 1 collect down. So 3 over 2 minus 1 become half. So 9 plus 16t squared power half. Okay, and then plug in. Okay, plug in when t equal to 1. So we have n1. Okay, negative 4i plus 3j. Okay, this one plug in 1 after it's 25. Power half to become 5. So negative 4i plus 3j. Okay, we check this now. Vector, unit tangent vector and normal vector are actually orthogonal. So this is you see 3i plus 4j divided by 5 is negative 4 and negative 4i plus 3j divided by 5. This is a unit normal vector when t equal to 1. Before it, you can see T1 and M1 are actually orthogonal. In this case, thank you for your attention.